Welcome to Digital Thread Bytes, a workforce development podcast produced by Sinclair College and the Dayton Development Coalition in Dayton, Ohio. In this podcast, the team discusses the coming revolution in digital engineering, highlighting digital transformation success stories and opportunities for learning. Here are your hosts, Jennifer Gravitt and Elizabeth Generas.
Well, hello, everyone, and welcome back to the Digital Thread Bytes podcast, season 2, episode 1, I guess, Elizabeth. This is technically episode 10, right?
Yeah, I don't know how we're going to count it yet.
I don't know how we're going to keep track of that, but
season 2.
Yes, and thanks for hanging in with us. And we've had a lot of interest in, are you going to keep this going? And here we are. What a kickoff we have today. We're very excited because, as a lot of you know, there's been so much buzz about digital transformation and it's coming, and be prepared. But we are going to explore more of the application side of this and those folks who are actually doing, the doers, as they're getting called now in the arena of digital transformation. So today, we are so thrilled to have Dr. John F. Matlik, Chief of Capability for Digital Engineering at Rolls Royce Corporation, to learn more about how Rolls Royce, a powerhouse in defense and aerospace, applies the digital thread and what that means for their operations, their suppliers, and their customers. And John is just a wealth of information, so we're very excited. Welcome, John.
Thanks, Jennifer. Looking forward to it.
I was in my head trying to remember how we met, John, and I think it was through the summit, the Dayton Digital Transformation Summit. So yes, thank you, John, for being here with us today. For me, when I heard Rolls Royce, I did not realize the extent that they worked in aerospace, actually. So meeting you, I learned a lot about what Rolls Royce does in defense and aerospace. If you could tell us more about what you do at Rolls Royce and what a chief of capability for digital engineering does.
Sure. Thanks, Elizabeth. Yeah, so that term, digital engineering, can mean a lot of different things. So at Rolls Royce, just a quick baseline. Digital engineering for us is how can we better leverage things like data, modeling, and simulations to make better and faster decisions, ultimately to deliver customer and business prioritized outcomes. So how can I do more in a virtual world and do less in the physical world where things may cost more and may take more time? So that's kind of initial context on baselining of what digital engineering capability is. So in my specific role, I have the honor of working with a world-class team of doers that develop and integrate. They do validation work and deploy digital engineering capability that we just discussed in response to the prioritized outcomes from customers and businesses accordingly. So I think there's like 3 key tenets, I guess I would say, that are basic, that set sort of that basic context for my role. The first one is around focusing on value, not focusing on digital. So what does that look like? That really looks like engaging our customers directly, engaging our business and our program teams to really understand what those key outcomes are that they need. Those outcomes could be risk reduction opportunities. They could be specific opportunities for cost avoidance or cost reduction. It could be an opportunity to deliver something quicker than they could do otherwise in the physical world. Then we kind of deliver that relevant digital capability that we need, not as a capability push on the customer on the program, but as a response to what they're asking for. The second key tenet of my job is to make sure that we're establishing trust in the models that are being used to make those decisions. So I think, everybody's probably heard this many times, and I know my team gets irritated with me, but George Box's excellent quote on "no model is right. Some of them are useful" is still very relevant today. We at Rolls Royce have a very robust process. We call it our verification, validation, and uncertainty quantification process. It kind of helps us establish the trust in the models and the simulations and the data that we use to make decisions. So we really need to have a good, confident view of what the model credibility is, and we need to have a good quality assurance process in place to make sure that the models that we have are good to go for the purposes and the decisions that we're making to use. And then the last kind of key tenet, 3rd out of 3, is that we win through collaboration. So I think, I've shared this before as a part of the Dayton Digital Summit, but, the systems engineering 101 statement, failure occurs at the interfaces, is also very relevant. We have a lot of interfaces when you think about cross life cycle and across supply chain. With all those interfaces, there's a lot of opportunities for failure or miscommunication. So that digital engineering capability and digital collaboration more broadly can actually help a lot with that by being clear about information and making sure that we have the necessary communication and coordination across that larger enterprise. And so collaborating and partnering is really important. And so that's the third and kind of last key tenet for my job is how do we build those necessary collaborations to win for the warfighter? So hopefully that was helpful.
That was very helpful, John. When you're talking about doing more digitally, less physically, quality, trust, collaboration, it's incredible because we've heard a lot about culture. We're just seeing a lot of change. And so with all of that being said and what you're doing in your role, how do you see digital transformation changing the landscape of manufacturing and engineering?
So in several ways, but I would say that probably one of the key ways that I see in the role that I have and how we see things transforming here at Rolls Royce and with some of our partners is really around doing things virtually in a computer to accelerate, de-risk, or reduce cost of what we would otherwise do in the physical world. So that kind of said that a little bit and is a part of my role in the first question. But I'm going to get tangible on that with some specific examples across the digital thread, because there is a lot of hype in this area, and you want to make sure you like, hey, is this real? So I'll just, give a couple of examples that you can kind of point to. First off, you may have seen in the news where Rolls Royce digitally modeled, twinned the wing and the pylon with the engine to win the B-52 contract. So there's a lot of details on that's already published as a part of the Air and Space Forces magazine, and you can Google that and it'll pop up for you. But it was a way to better manage de-risking of things up front and demonstrating a low-risk solution and the perfect fit for an engine from that platform. That was one example. Another example is around advanced visualization, or you might call it virtual reality or augmented reality. We've got several examples at Rolls where we have orders of magnitude in returns on investment through cost and time savings by near zero cost prototyping in a virtual space, where we use virtual reality to assess form and fit of some solutions that we're looking at. Example one, we've had a test engineer that reviewed a test rig for accessibility in 3 dimensions, not just on a flat computer screen, to get a feel for, hey, can I reach around this pipe? And actually, we've identified in like 30 minutes, we identified about a handful, about 5 or 6 different issues that would have cost about several months of time and millions of dollars if we had gone and learned that in the physical space. That's example one. A second example on the advanced visualization piece. From a sustainment perspective, when we're designing engines, we now get sustainment engineers into an environment and look at how sustainable or serviceable or maintainable is that engine to begin with. And as a part of the upfront design reviews, we're able to catch things and design things so that they are serviceable or maintainable, looking at on-wing maintenance, for example, as opposed to having to take an engine off-wing. There's some pretty powerful things you can do all in a virtual world on that front. And as a third example under advanced visualization, I can kind of point to an award Rolls-Royce got for our AE 2100 virtual reality fully immersive maintenance training. You can actually Google that and see a little bit more context on it, but it's how do you actually train folks in a virtual environment so that when they get out there and they put their hands on the real engine, they can do it quicker. They learn it faster, right? And so virtual reality allows you to kind of speed up that learning process, and it's pretty powerful on that front. We've seen through application of model-based systems engineering, so that's managing requirements and interface design, we can reduce the time from requirements to first hardware in the loop test by 50%. If you look at how do you digitally define a 3D solid model with its product and manufacturing information and how that supports automation, that's called model-based definition. We've done a design change and a manufacturing change process and updated that, leveraging MBD that went from what took 12 hours before to now 12 minutes. We've had physics-based simulations and trust of models to allow us to de-risk, reduce physical testing, but also to ensure efficient and effective simulations where we may not run an expensive simulation if we know it's not going to get us what we need. We've got some examples on digital inspection for material review board and maintenance, repair, and overhaul applications where we use functional-based sentencing with data and digital representations of those parts, as opposed to just looking at it by I don't know, caliper and making a judgment call from a service engineer perspective. And we've seen 25% or more reduction in scrap through use of those sort of automated, functionally based sentencing of turbine blades and vanes in particular, as an example. So another tangible example. And then lastly, Rolls Royce, along with some of the others out there, you've heard about software factories. Well, we have our own software factory team, and they're an awesome team of doers. They've been delivering orders of magnitude faster development of software through the use of agile software development and DevSecOps. So we're able to go from what would have maybe taken 2 months previously to 2 weeks. So, speed and the lower cost solutions are really coming out in terms of digital engineering. These are just a few quick snapshots to show just a small picture for how digital transformation is really impacting industry's ability to deliver better solutions faster and at lower cost.
I mean, you said small picture, but that is not small. Those are not small numbers.
It's like application on steroids.
Yeah. You talked about hype, that there's still hype out there. And I think you gave us some great examples of what is actually happening. But what are some of the myths, some of that hype that you're continually having to redirect people to what's real?
Thank you. Yeah, and it's an excellent question. First myth, I guess I would highlight is that digital, people will say it's about the tools, or there's an app for that. Yes, there are some cool and very powerful applications that are out there, but capability involves people. It involves processes as well as tools. It involves culture, right? So perhaps more importantly, when we talk about the whole transformation landscape, we need to consider that broader cultural and workforce landscape and aspects. So as an example, Rolls Royce has a holistic view for what that workforce development looks like. So one example in terms of how do we look at even STEM education and workforce development. So at a national level, Rolls-Royce is a prime sponsor of the Air and Space Forces Association's Teacher of the Year Award. So we support educators who are developing the next generation of science and technology leaders from coast to coast. That's national. From a local perspective, Rolls-Royce supports local colleges and universities like Sinclair Community College, and a big shout out to you guys for what you're doing on the Digital Thread Bytes activity. We showcase the exciting ways digital is transforming the industry, and also the associated possibilities of a career at Rolls-Royce. So it is a very exciting time, but we have got to consider workforce. But the second myth, I guess I'd highlight, is that we simply need to digitize the way we do things today. So as a part of Rolls-Royce's strategy speaks to reinventing with digital, not just applying a digital tool or a software solution on top of the way we've always done it. You got to be careful in those contexts, because we have done some of that, and we can find that doesn't decrease cost or reduce time. It can go the other way. So you really do need to consider the processes, the culture, the people, in addition to just saying, hey, I'm just going to apply this digital tool on top of all of these. You can't just simplify what you've already done today. And so you really need to think that through. And then lastly, I guess I'd highlight is that it's all about digital, or it's all about engineering. So if you recall, one of my main challenges and tenets for my job is to make sure we focus on value and not on digital. And I would almost say not only engineering. There are many functions and areas that must partner together to support the needed transformation. That includes, beyond engineering, that includes program management. It includes contracting. It includes finance. It includes intellectual property counsel. It includes procurement and many other functional areas. So I think that's the kind of last myth that I just highlight here is just, it is more than just digital, and it's more than just engineering. We are on a team contact sport across many functional areas, and we got to work together to realize the value for the warfighter.
That was a fantastic way to kind of unveil those myths, and it touched on so many spokes in this wheel. With all that being said, what keeps you up at night, John?
So another great question. I think if I were to answer it, in our current landscape where things are moving so fast, we've got a lot of emerging capability. We have some pretty significant international threats, right?
Right.
In my job, I have to get capability into the hands of the programs and into the warfighter fast. So for me, I would say what keeps me up, it's how we scale. How do we scale up our emerging capability to meet the warfighter needs, and doing that at the speed of relevance? So in our team, we do have a fast pace of looking into new capabilities. So we do think big, we start small, we learn fast, and then we scale what works. There's been a lot of focus recently on the first three of those and looking at like, how do we get agile? How do we do sort of pathfinder work and proof something out really fast and learn about it? And that's great. But scaling that solution up at speed, when you have to ensure that you're staying safe, that you have to make sure cybersecurity for systems is considered, and in particular in highly regulated systems that have to go through regulators, is hard. So, when you're having to deploy those new technologies and get the regular buy-in or broader supply chain adoption and collaboration, when you're doing all that within one organization, we can get benefit. But as soon as you start looking at needing to work with the thousands, literally thousands of suppliers that we work with in order to realize this, it's hard.
I really appreciate that you framed this as it's hard, because I don't think we say that enough. This is not an easy problem to
easy
solve.
Button.
No easy button.
No.
If someone listening today wanted to know more about Rolls Royce or more about digital engineering, what kind of resources would you connect them with?
It's a great question. And definitely this is an enterprise thing. So please, if you are a passionate participant and you are listening, jump in. And we'd love to have you, collaborate and partner. So first, if you want to know more about Rolls Royce and our Digital First initiative, you can Google Rolls Royce Digital First, and it'll pop up with context on our page on our digital strategy and some of the examples where we are realizing value from digital for our business and for our customers. So please have a look at that. Google Rolls Royce Digital First. But more broadly, and honestly, more interestingly, from the context for a discussion today, this is an enterprise thing. So we have several professional society efforts that are aimed at enabling collaboration to realize value from digital engineering. From an aerospace perspective, I can't think of a better one to point you to than the AIAA, American Institute for Aeronautics and Astronautics. They have a Digital Engineering Integration Committee, which I'm heavily acted in, along with all of the other major OEMs from a defense and aerospace perspective. But that's, if you Google AIAA, Digital Engineering Integration Committee, you'll have a lot of things that pop up, and you'll see how AIAA partners with AIA, NAFEMS, INCOSI, OMG's Digital Twin Consortium, and many others. And you'll see position papers that are out there on digital thread, digital twin, that establish what is the value the aerospace industry sees in terms of value. What are some of the implementation recommendations and next steps for us as an industry to move forward towards realizing value in this space? So, please go out and check it out. Lots to learn out, and then you can reach out then through that landscape, and we would be happy to kind of onboard you into our passionate set of participants that are moving this out. And then finally, just again, I got to close out and do a shout out to Sinclair. This is an excellent series because you're raising awareness for digital thread and digital twin, huge transformation that needs to go beyond. When we talk about scalability, what keeps me up at night, you guys are part of the solution to that. How do we help scale across that broader landscape and that broader enterprise? Thank you for making this accessible, not just to OEMs, but also the small and medium-sized manufacturers that really are going to be critical in what we anticipate is coming. Thank you for that. And then lastly, I guess I would say that another great place to check out, Sinclair, I in fact hosted this year's Dayton Digital Summit that Elizabeth was referencing earlier. It was sponsored by the Dayton Development Coalition. I just wanted to highlight some excellent content that's captured on their website, Sinclair's website, the Digital Thread Initiative webpage. Some of the AIAA reference work can be found there, as well as some guidance for how to follow up. And I just would point folks in that direction. But thank you for all that you do, and thanks for the opportunity to join today.
Thank you so much, John. It was just packed with information, and that's exactly what we expected from you to launch season 2 of this Digital Tapestry series, and never a disappointment. So we hope that many people can get lots of information from what you've shared today.
Thank you for listening. The hosts would like to thank Sinclair College, the Dayton Development Coalition, and our guests for exploring the digital thread. This material is based upon the work supported by Air Force Prime Contract number F48650-16-D-5524. Manufacturing and Industrial Technologies MITS, Task Order J, Regional Fabrication and Certification Training Labs, an Air Force Mantech project managed by Arctos Technology Solutions. Any opinions, findings and conclusions, or recommendations expressed in this material are those of the authors and do not necessarily reflect the views of the Air Force or Arctos Technology Solutions.